You've probably seen these beautiful 3D print time-lapse videos, but have you ever wondered how they're actually captured? If you just put your phone or camera in time-lapse mode and record your print, you'll end up with something shaky like this. In this video, I'll show you how to capture smooth layer-by-layer time-lapses with any 3D printer. When your printer is running, both the bed and the extruder move constantly, so every time your camera takes a frame, the printed object is in a slightly different position than before. So, how can we fix that? Well, after each layer is printed, we need the printer to move the part to the exact same spot every time. And to make that happen, the solution should be somewhere inside our slicer software. After a bit of searching, I found that Cura actually has a built-in feature for this. Just install the latest version of Cura, go to Extension, Post-Processing, Modify G-Code and click Add a Script. Then select Time-Lapse Camera. You'll see this settings page. Here we can choose where to park the print head using the X and Y positions. Since my printer's maximum X and Y are both 220mm, I'll set them to 220. You can also add a short pause before or after taking each image. I'll just leave the defaults for now. In here, from this drop-down menu, you can set how often to park the print head and take a picture. It's set to every layer by default. Once we're done with the settings, just close this tab. You'll see this new icon here. That means the extension is active. Now you can slice your part, and the time-lapse comments will automatically be added to the G-code. That's for Cura. Let's also check Prusa's slicer. It doesn't have a built-in extension like Cura, but you can add one manually. Go to the Printers tab and find the Custom G-code section. Then add this code in the After Layer Change field. The first line tells the printer to park the head and bed. Just change the coordinates based on your printer's X and Y. The next line makes sure the move finishes completely. Then we wait 500 milliseconds before continuing the print. In other slicers, you might find a built-in time-lapse feature like Cura, or you can add a custom G-code manually like in Prusa's slicer. Now let's print using our new G-code. As you can see, the bed and extruder park at the position we set after each layer. But we still can't capture the time-lapse we want yet, because each layer takes a different amount of time to print. That means we can't sync our camera's time-lapse interval with the layer changes. So instead we will take a single photo at the end of each layer and then combine them into a time-lapse later. Of course, I don't want to stand there pressing the shutter button for hours. But before doing something about it, let me quickly introduce PCBWay, the sponsor of this video. Besides making PCBs, they also offer 3D printing services. So if you don't want to spend a lot of money on different materials and printers, or deal with tricky setups and tunings, you can simply upload your model on their website. Then set the quantity, or you can even submit bulk orders here. Now pick your material and the color you want from a bunch of options. The cool thing I found here is that you can print metals too. After filling in the basics, you'll instantly see the price and you can submit your request. You can also use the link in the description to get a free $5 credit on your order. Alright, back to the build. For automatic capture, I decided to use this Bluetooth shutter. They're pretty cheap and work with almost any smartphone. You can also find similar ones for most cameras. Now we just need the printer itself to press the shutter button automatically each time it parks. You can attach something like a small finger to push the button every time. But that's not very reliable. If you look closely at your printer, you'll see small micro switches. These are used to detect the zero position. That's exactly what we need here. I had one with a roller lever, which should work perfectly. It has 3 pins: common, normally open, and normally close. We will also need a mount to hold the micro switch where the printer head can press it. So I designed and 3D printed these parts. Now we just have to replace the Bluetooth shutter button with this micro switch. To do this, we will need to disassemble the shutter. It doesn't use any screws, just remove the battery and gently pry apart 2 halves. I'm gonna replace the larger button with the micro switch. We also need to remove this snap so we can route the micro switch wires through its hole, and then reassemble the enclosure. For removing the push button, add some flux and heat it with a hot air gun. I'm using a multimeter to find which pins should be connected to the micro switch. This pin is grounded, and this one is connected to the IC. Now connect 2 wires to these pins, one for the common pin and other for the normally open pin on the micro switch. For convenience, I'm using a female SPAD connectors. They make it easier to connect and disconnect wires from the switch. If you don't have a crimping tool, you can use your needle nose plier to attach them. Just do it gently to avoid cutting the wires. I also soldered the connections to make sure they are solid and reliable. And that's when I realized I messed up. I forgot to pass the wires through the hole in the shutter casing first, so I had to desolder them, pass the wires through the hole, and solder them again. Reassembling the shutter is simple. Just align the battery plates, make sure the power knob is in place, and snap the two casing pieces together. Then pop the battery back in. I also add some heat shrink tubing over the connectors to prevent any short circuits. Next we can assemble everything. First insert the nuts into the hex hole on the printed parts, then secure the micro switch in place with 2 screws. I also made a small hook so the shutter can hang easily on it. Finally, connect the shutter wires to the micro switch. It's now ready to be mounted on the 3D printer. This part fits into this hole on my 3D printer and prevents it from rotating. Insert a screw through it, place the smaller part on the other side and tighten it. Now we need to find the exact X position where the print head triggers the micro switch. On my printer, it triggers at 218mm without applying extra pressure. So I'll set the park head X position to 218 and slice the model again. As you can see, after each layer, the print head presses the micro switch and the phone takes a single photo. But the result doesn't look quite good. It seems the camera takes the photo when the printer starts moving. That's because the shutter sends the signal when it's released, not when it's pressed. To fix this, we need the printer to press and release the switch without moving the bed. Cura time-lapse extension doesn't have a built-in option for this, but there is a camera trigger comment section that accepts custom G-code. You can add your own comments here. This line will run right after the printer parks the head. So add this code here and replace 215 with the X position where your head releases the micro switch. You can also add the same G-code manually in Prusa Slicer like this. So let's see if the changes work. After watching this satisfying time-lapse, check out this cool DIY too. Enjoy this video, hit that like button and subscribe for more awesome projects. See you in the next one.